we're going to now ask Brian to come and talk to us about the 2-meter next generation beacon program. So Brian, it's over to you. That's Brian, ZS6 Yankee Zulu.
Okay, Hans, you can tell me if you can see the screen there.
Yeah, I can see your
audio
screen.
okay.
And your audio is okay. And your glasses look cool. There's a bit of a lot of reflection from the lights, but go ahead.
Yeah. Great stuff. Probably better like that.
Okay.
Okay, guys. Ladies and gentlemen, we're going to be speaking about the SARL Next Generation Beacon program. And we're going to answer a couple of questions, and we're going to look at what the progress of the program is to date. So firstly, why VHF and up? There are two big myths. The first is that VHF and UHF is not just an FM and repeater band. There is so much more that one can do on these frequencies. Also, VHF is not line of sight. Signals get refracted in the atmosphere. They get reflected, they get diffracted, and they get scattered. And all these things that happen to the signals enable us to be able to hear VHF and UHF communications a lot further than what we think we can. And VHF and UHF frequencies can achieve very, very long distances. You've seen the reports about the St. Helena beacon that's heard in South Africa, and that's a long distance. And even within the country here, we've had some very long distance communications already on the VHF and UHF bands.
There we are. There we are.
Okay. Okay, so the other thing, the VHF and up bands are very underutilized, and we need to start using those bands. And as Nico said, it's a use it or lose it situation, and the bands are under threat. In my program Focus on VHF, I've spoken a lot about some of the threats that we're experiencing, and where people have actually got us under a magnifying glass to see, are we using those bands, and trying to build a motivation that they can request that they rather use the bands than what we have. And then the other thing, when there's little or no HF propagation, when the ionosphere is not performing as it should, then there may be propagation on the higher bands above 30 megahertz. So why is a beacon important? We think that we know a lot about propagation on the higher frequencies, and in reality, we actually don't. There's very little that we do know about these frequencies and how they propagate. And the radio amateurs are uniquely positioned to make contributions to science. If you think about it carefully, our radios that we got are actually very accurate measurement instruments that we can use to do all sorts of things. I've participated recently in hands-on events where my HF radio is being used simply as a receiver, but we're making very accurate measurements on a certain frequency, and then the data is being sent back to scientists who then analyze that and correlate the information, and they can find out more things about the ionosphere, what's happening in the ionosphere, and especially being able to have measuring stations across the world that can make these measurements and send data back to them. And that's why the scientists are very interested in working with the radio amateurs in furthering some of their studies that they're busy with. So each one of us sits with tools in our shack that can be used to make a contribution to research and development within our hobby. Now, the reception of a beacon signal is an indicator that an RF path is open in a certain direction. But not only that, where a beacon is received, it will allow us to be able to study propagation so that we can better understand how the propagation is actually working. So what is a beacon? A beacon is quite simply a transmitter which is sending out a signal in an omnidirectional area 24/7, and that's very important. A beacon, if a beacon is running properly, it must be on 24/7, 365 days of the year. And it's there purely for the purpose of propagation research. Here we prefer to use a directional antenna, a Yagi, because we're pointing the beacon at certain areas where we know that there are amateurs and there is activity. So there's a possibility of an amateur being able to receive the signal that we're generating. A beacon can send out a CW signal or a machine-generated message, a MGM signal as we know it. So let's just go back a little in the history of the Beacon project. Back in October 2018, we had a VHF workshop at the National Amateur Radio Center, and I gave a presentation on beacon coordination. And at that workshop, it was decided amongst the participants that we need to start a VHF work group to drive a beacon project where our primary objective at that time was to put a beacon up in the Karoo, in the center of the country. And as you can see on the map there, when we talk about the northern Karoo, more or less the area of Hopetown, Van der Kloof Dam, that area, it's equidistant between Gauteng and Cape Town, where the two big centers of VHF activity is. Around the rest of the country, there are VHF enthusiasts who play on the bands, and you'll hear a little later how they've also managed to receive the current beacon that is up in Bethlehem. So the Karoo beacon site, the biggest challenge is to find a suitable site. It's in the middle of nowhere. There's very few amateurs. So in our process of looking for a suitable site, Rick ZS4 Alpha offered us a site in Bethlehem in which we can use as a beacon test site. Now, Bethlehem is a suitable site for us because we've got a radio amateur that is a custodian of the beacon there. He's also a very active VHF, UHF amateur, and it is not very far from Johannesburg and Pretoria. So if we need to go to the site to do something on the beacon or something like that, it's not that far to travel for us. And that's also one of the challenges when we eventually get a beacon up in the Karoo, is it's in the middle of nowhere. Whoever is the custodian of that beacon has to understand how the beacon works, everything to be able to do basic troubleshooting on it. In any case, we went through a whole series of testing and ideas, and we eventually came up with a solution that worked very well. It went live in December 2019. And it is a modified FM radio. You can see the picture of the radio. There's an ICOM radio. And what we did was the eventual solution is we were using a simple microprocessor controlled keyer, which switching the power amplifier on and off to generate our CW signal. And you can see the photograph of the beacon as it is currently in Bethlehem. In the meantime, we've had a little hiccup with some lightning, and this power supply that was shown in the photograph took a lightning strike, and since then we've replaced the power supply and we've put in the necessary lightning protection as well. So yes, it was very successful. The beacon was heard not only in Gauteng. There's two antennas, one pointing towards Gauteng and one pointing towards Durban. It was heard in Kimberley. It has even been heard as far as Hopetown, if I remember right. And it was heard in the Northwest Province as well. And that's not even in the direction that the antenna is pointing. So there is something that's allowing propagation of the signal to those other areas. And it's these unexpected results which intrigue us and which has fueled the quest to continue developing the project. But it's not good enough just to have a beacon in the air that's transmitting signals. We need a way to monitor it. And the way to do that is to have a reverse beacon network, where it's a network of stations that's listening to the bands and reporting what stations they hear, how well and when they heard. This system needs to run automatically, totally by itself. And if you've listened to the various VHF workshops and presentations that I've given in the past, I had a presentation all about reverse beacon networks. And once we had the beacon up and running, I started playing around with software to try and see how we can receive a CW beacon, and I came across CW Skimmer. A lot of the HF guys that are active on CW will probably know the software. It decodes CW signals. It looks for stations that are calling CQ, and that's one of the reasons why the current Bethlehem beacon has actually got CQ, CQ, ZS0, Bravo, Echo, Tango, because that CQ is a key that the CW skimmer uses. And then it sends reports to a reverse beacon network. So a reverse beacon network are things like DX maps, which displays it, PSK reporter, which displays your propagation and so forth. But we discovered a couple of things about CW skimmers that was not working for us. The one thing that we had was the CW skimmer must receive a signal that's of a fairly high level. And we found that we can hear the beacon already long before the skimmer can recognize it. So that doesn't help, because we can receive the beacon when it's still fairly weak. We can just make it out above the noise level, and the skimmer can't identify it and report it. That became a problem for us. So then we started experimenting with some digital modes, and specifically Carl, the ZS6 CBQ, and Rika, ZS4 Alpha, started playing around with JS8 call. And JS8 call has got a heartbeat function, and the heartbeat function is nothing other than a beacon that it sends out. And of course, with JS8 call, we can automatically receive it. I mean, a JS8 call station can run totally unattended. And then based on their test that they did, the work group decided that we need to explore digital beacons further. I, in the meantime, discovered a presentation given by Bo Hansen, Oscar Zulu 2 Mike, who's in Denmark. And it went about PI4, the digital mode for beacons and why it is a success. And it was a very interesting presentation to watch. And then we contacted Bo, and he offered to give a presentation to the VHF Work Group. So we arranged that, and that happened on the 20th of June. And after listening to the presentation and discussing it amongst ourselves there, we decided that a next generation beacon checks all the boxes. And basically we were sold. That's the direction that we need to go on. So why a next generation beacon platform? What we discovered through the presentation that Bo gave us, that every digital mode that's out there has been designed with a specific propagation type in mind. And it's not a case of one shoe fits all. So there's a place for whisper beacons. There's a place for all the other types of beacons that are out there. So one has to bear this in mind when you playing with a beacon. So the PI4 code, which was developed for the beacons, stands for Ferris Ignis 4, which comes from the ancient words for a beacon or lighthouse, and fire, Pharos, which turned to Pharos in Latin, and of course coming from the lighthouse of Alexandria, and the igneous is Latin for fire, and then the 4 stands for the 4 FSK tones that it uses. This software system was designed to be compliant with the IARU Region 1 VHF committee, with the accepted standard and the sequence that they proposed, which is a 1-minute mixed mode beacon sequence. The nice thing about the next generation beacon, for the traditional CW user, it sends out the CW sequence and you can actually hear it. So if you're interested in just monitoring the CW portion of the beacon, it sends out that out in as part of the sequence. The beacon also caters for the digital user, which is where primarily the Beacon project is all about. It sends out a PI4 message, which is machine generated, and this message is what can get decoded by the software. And then the third thing that it's got is an accurate carrier frequency or frequency checking. The beacon is GPS disciplined. In other words, it is accurate, very accurate frequency and time. And we've already tested here locally when the beacon sends out just the carrier, and you can then turn your radio's dial and you can get a 0 beat on it, and then you know how far you're off frequency also with your radio. The digital sequence that it sends out, the PI4 code, can be decoded and reported the same as in any other digital mode. It reports it to a reverse beacon network, like PSK Reporter, a DX Atlas, and those places. You can decode it with PyRX. It's a program that can be downloaded off the net free of charge that runs on Windows. And then the MHSV software package, which a lot of the guys use for digital modes, has also got a PI4 mode that you can select, and you can then use that for your decoding. MHSV runs on Windows, and it can also run on Linux and on a Raspberry Pi. So one can get it running on multiple types of computers. The other nice thing about the next generation Beacon platform, it is not bound to a single frequency. So we can actually support multiple beacons on different frequencies on the same site. And when we talk about the hardware, I'll explain how that's possible. So the beacon hardware, there's basically a block diagram that you see. The red block corresponds to the VCO and phase lock loop board, and you can see a photograph of it there top left. The GPS, it gets a signal from the GPS board, which is the blue board at the bottom left here. The GPS reference provides a very, very accurate 10 megahertz signal to the VCO and the phase lock loop. The VCO and the phase lock loop then generates a 1 gigahertz signal, which gets sent to the direct digital synthesizer. And the direct digital synthesizer is actually the board that generates in our case, the 144.425 megahertz frequency. The DDS board also gets a time link, an accurate timestamp that comes from the GPS reference board. And if that time the GPS signal is not locked, then the DDS will only put out a CW signal and a frequency accurate tone. It will not put out the MGM message, the PI4 message. Once the GPS gets locked, then the PI4 message is also transmitted in the sequence. So if you listen to the beacon, you'll hear the PI4 message, then you'll hear the CW message, and then you'll get the tone. And they're all about the same duration. So the service management is an optional thing that we don't have because it's not required. You can actually connect your computer directly to the USB port on the DDS and change frequencies and modes and so forth. And then we have a power amplifier and a low pass filter chain, as any transmitter has. And in this case, we're using a Mitsubishi power brick, same that you find on a lot of commercial radios. It puts out 30 watts, and it's an RF amplifier which is pretty much robust. Now, to be able to support multiple beacons, what you have is you have a GPS reference board and a VCO phase lock loop board. And then you have a distribution amplifier. So the 1 gig signal that's generated by the VCO goes through a distribution amplifier, and you will then have a DDS and a power amplifier chain for every frequency that you want to use. So then you've got, they are all locked to the same reference frequency, and then you'll have, for every band that you want to have a beacon on, you can then have a DDS board and a power amplifier for that particular band. So that's fundamentally what the hardware looks like. So let's have a look under the hood of our beacon. We built the beacon into an old Storno repeater cabinet that Rossi managed to get us. When we open it up, it's basically a 13-kilogram heatsink, the cabinet. It is fantastic. So we have a low-pass filter here going out on to the antenna. There's a power supply inside it, a power supply module. And then on this side, we've got two cases. And when we open the lid on those two cases, you will see here's everything. There's the GPS board. There's the VCO phase lock loop board, the DDS with this cover on. And there's the power amplifier with a little bit of circuitry there just to control the power on the power amplifier. And we have a little auxiliary power supply feeding the DDS, because the DDS only runs on 5 volts, whereas the rest, everything else runs on 12 volts. So we're just stepping the power down to from 12 to about 7.5 volts, so that the regulator inside the DDS does not get too hot. A closer look at it, you can see this is the GPS board here. We have a 10 meg signal that goes to the VCO, and then we have a fiber connection which goes to the DDS board as well. So the output of the phase loop board is a 1 gig output, and that goes on to the DDS board. You can see here the 1 gig comes in, and the fiber with the timing information coming from the GPS comes on the fiber link over here. Here we have the RF frequency that we're using, 144.425 is generated through this board, through the amplifier. I've put a pot into this. All that this board does is provides biasing for the amplifier. So I've put a pot in it so that I control the power out from the amplifier. So when we run it on the bench for testing, we drop the power down to 5 watts, just so that we don't overload the dummy load that we're using here for testing. But that's fundamentally what the beacon looks like. The beacon was up for testing, it's now in its 2nd week of testing. There it's live on the air. And in the 1st week of testing, the antenna was pointed towards grid Kilo Foxtrot 59 Juliet Romeo, which is in the direction of where Derek ZS5 Yankee lives in Scottsboro. And on that first day that it was pointed to him, he received 88 decodes in the afternoon, ranging from -21 to -9 dB, and that was in a time range in the mid-afternoon. And it was absolutely amazing to be able to get this validation that the system is working, it's being decoded and everything. And Derek actually made the comment, it's a great propagation study tool indeed. It tells us so much more already than we knew. And to me, this is fantastic, because this is the validation that all the time that we spent in this beacon up and running, it actually works. So the next steps, we need to deploy the beacon at the Bethlehem site as soon as possible. So it's basically just a drop-in replacement for the existing radio that's there. During the testing, we've picked up in this last week that sometimes the GPS is not locked. I need to try and figure out why that is happening. And then probably around middle April, in that time frame, we will get the beacon installed at the Bethlehem test site. Then we need to get some monitoring stations up and running that can record and collect data. And again, yeah, any amateur radio or SDR dongle that is capable of receiving an SSB signal at the frequency that of the beacon, you can use it. It's like you would receive any digital mode that's currently out there. Computer or Raspberry Pi with software like PyRX and MSHV is all that you need, and then obviously internet connection so that the software can send the information back to the reverse beacon network. There's interest in replacing the current Cape Town 2-meter beacon with a next generation beacon platform. There's also the Karoo beacon is still our ultimate goal. And our plans at this stage that we're talking about it is this is going to be a mega beacon because we're looking at putting up 4 antennas pointing in 4 different directions. And with those antennas, we should virtually cover all the centers of VHF activity in the country that we are aware of. Each antenna will have its own power amplifier, so we'll be able to put full 25 watts into the antenna. And they will all transmit simultaneously. And because of the location, we would probably need to be solar powered with the beacon as well to do that. There's still a lot of planning that's going into here. We are still busy looking for sites, and Cole's ZS6 CBQ is basically running with that, along with SARL ZS3 Kilo, who's in that area. He lives and works in that area. And Charles is looking out for possible sites and so forth. We've identified some sites that we're busy looking further into. And as it progresses, we will formalize the site negotiations with the farmer who owns the site and so forth as well. But there are other locations for beacons as well. And what we're working on now is just the start of the project. There's just so much that we can do with this. Originally with our presentation that Bo Hansen, Oscar Zulu 2, Mike gave us in the VHF Work Group, he had a look at the map of Africa and with his experience with beacons and stuff, and he's the beacon project manager for the Danish Amateur Radio Society. He placed a couple of beacon locations on the map for us. So you can see in the center of the country is the one that we intend to are planning on. He spoke about a beacon down in Cape Town to test the path between South Africa and South America. There's been a fair amount of activity as well between the east coast of South Africa and Mauritius and Seychelles. Okay, the trop propagation is not as good as what it is on the west coast. And then there's also to explore the path across the southern Indian Ocean to Australia. And then, of course, between South Africa and Europe, we've got trans-equatorial propagation that can take place, and a beacon somewhere in the northern areas of South Africa pointing north, generating a PI4 signal would be very useful for amateurs in Europe. The nice thing about having a beacon that can run 24/7 and a system that's monitoring that beacon automatically 24/7, you as an amateur do not have to be in front of your radio. But your radio can be very useful to us by recording the data on a continuous basis. And then we can collate this data and then start looking at what we are seeing. Because I can guarantee you that there's tropospheric propagation that we're not even aware of, that we can use for, to have long-distance QSOs. So some of the activities, of course, when you're running a project like this, we have to talk about it. We have to advertise it. The more we talk about it, the more people become aware of it, and the more people become interested in joining a project. And of course, a project like this is expensive as well. So at all the AMSAT and SARL workshops, there's always a presentation on the beacon, the progress, where we sit running with it. There are articles published in a trade magazine, Engineer IT, where Hans ZS6AKV is the editor, and he regularly asks me to write an article or provide information that we can put in a column there on amateur radio activities. And then AMSAT SA is also supporting the project with a crowdfunding initiative on their website, where you can, via PayPal, make a contribution to the project. And it would be great if we can get more contributions to help fund this project and to take it to the next level. We also had the opportunity and the privilege to be able to present our project at the last HAM SCI workshop, which was now last weekend. It was, for us in South Africa, it was 7:30 in the evening when our presentation was. But we managed to do a successful presentation, and it was to a lot of amateurs and scientists who are amateurs in the United States and across the world that are interested in ham science. And one of the interesting comments that came out of that, one of the American guys said that he wishes that the American amateurs would move away from CW beacons and start using digital beacons, because there's just so much more that one can do with it. And I found that a very interesting comment. There is a link, and we can make this link available on the SARL website as well, where you can go and have a look at the iPoster, the presentation that we put together for the HAM SCI workshop. So just a little bit of extra information. The VHF Work Group. This is basically the steering committee for the Beacon project. We meet once a month on Skype, where we update what's happening, where we're going. We discuss various things, and you can see the list of the people that are on the VHF Work Group. And anybody is welcome to join us. All you have to do is just send us an email with your Skype name to vhfnews@sarl.org.za, and I can put you on the meeting list. And most importantly about this project is that we need you to help and to participate in this absolutely exciting research project. And I say exciting because now the project is really getting exciting. We've already figured out what we need to do. We've worked out what works, what doesn't work, and we have now clear direction where to go moving forward. And this project is going to be one of the exciting projects, and especially being a research-orientated project that the SARL is embarking on. And to me, the excitement has only just started. Thanks. Any questions?
Right, if you'd like to ask some questions, thanks very much, Brian, for an interesting presentation. Please raise your hand. And as I explained, you can raise your hand when you look at the people or the participants, and if you raise your hand, we will see who's raising his hand to ask a question. So ask questions now, or raise your hand now. I don't see any hands. Do I miss anything?
I must have blown them away.
Absolutely. Maybe they're all going to the AMSAT SA website to make their donations, Brian. Right, anybody else? Anybody's got a question that'd like to comment? Raise your hand. Right, if you can't raise your hand, just ask the question by opening your mic. Some people may have a problem looking for that facility. No, I've not blocked anyone.
Hans,
yes.
This is Pierre. I would like to ask, what are the requirements for a beacon site? Because I'm thinking that the Hermanus Magnetic Observatory terrain in Hermanus may be a suitable site, and I'd just like to find out what are the requirements.
Thanks, Pierre. Brian?
Well, Pierre, thank you. Yeah, it basically, if there's a tower that one can put an antenna up on, and then a place where, like a control room or something like that, where you would have the beacon running, and you need 220 volts, and be able to put a GPS antenna outside the building that can see the sky and see the satellites. That's all you really need. We would put a directional antenna up, pointing probably, well, from Hermanus, it's actually be an interesting site because you can point up west up the coast and east as well. And it will be a very interesting site to be able to test the propagation along the coast. And we know that there's great propagation along the coast, especially tropospheric, tropoducting propagation. So yeah, that would be a very, very interesting site.
Let's continue the conversation about that. I think we may be able to encourage science and help you contribute to the science that we're doing at SANSA and Hermanus.
Absolutely. We need
we
need
we'll
those science
up on that. Sorry, we talked together. Go, Brian.
Yeah, we definitely need the scientists to assist us because they got the skills in analyzing the data and being able to figure out what's being seen, because the data that we collect should be correlated with weather predictions, weather conditions, because this all happens in the troposphere as opposed to the ionosphere where HF propagation takes place.
Thank you. Anyone else? I'm sure we'll take it offline. Thanks very much, Pierre. Anyone else that's like to pose a question? You can't raise your hand. This talk doesn't look like there are too many at the same time. I don't see anyone raising a hand, and I don't hear anyone talking. So here's a last opportunity before we move on to our next presenter. Well, thank you very much again, Brian. It's a brilliant presentation, and yeah, maybe we should. I don't know if you can play the signal of what actually you hear when you go to the frequency, and also the frequency 144.
It's 144.425. Let me quickly pull up a sound clip for the what you would hear.
Nico's talking, but we're not hearing him.
Yeah, it's interesting. Yes, my mic is on, and Pierre, that is music to my ears. Remember visiting Hermanus quite often, and especially your facility for calibration of compasses in the good old days for aircraft use, master or reference units on that mountain is absolutely that will be absolutely ideal, second to none. So we will definitely take this up with you offline there. Thank you very much indeed for mentioning it, and it's a great opportunity to take things further for another possible site for a beacon. Hans, there we are. Seems like we've definitely blown everybody away with this presentation, Brian. So there you are. Have you found that nice clip there, Brian?
Yeah,
play
out the sound clip. So this is the PI4, the machine-generated message that goes out. That's just a small portion that message, and then here's the CW signal that is generated. Now this has been recorded at a frequency of 145.424 megahertz. So it's a 1 kilohertz down on the frequency. Yeah, so if you tune on CW, spot on frequency, then you can just detune slightly until you get your 600 hertz or 800 hertz tone that you're comfortable with listening. And of course, then the other tone is for frequency calibration. And of course, it's off by a couple of hertz because it's again recorded slightly off frequency. That's what you'll hear, that you can then zero beat your radio with, and then you can figure out exactly how far your radio is off frequency. And you'll be surprised at the higher frequencies how far off your radio is actually off frequency.
Okay, right. Thanks very much, Brian. And yeah, it's really a great presentation. We are recording, and hopefully we can twist Anton's arm to do the editing for us, and then we'll make it available on a YouTube channel, which we are busy setting up as well. But a little patience is needed. It'll take a week or two before we'll be able to do that. Too many other projects on the go at the same time right now. Thank